Hello everyone, and welcome to the video. In this video, I'll explain why we should use a client authoritative chaos vehicle system. Let's start with Unreal Engine's default chaos vehicle implementation in a multiplayer environment. As you can see on the screen, two different clients see the vehicle in different positions. So why does this happen? Unreal Engine's default replication model works like this. The player provides input, the physics simulation runs locally, and the vehicle moves on that player's machine. At the same time, as you can see in this function, those inputs are sent to the server every single frame using a reliable RPC. The server then forwards those same inputs to the other clients. As a result, the server and every connected client run their own independent physics simulation using the exact same inputs. The first major issue here is that a reliable RPC is being called every frame. This is something you should generally avoid in a multiplayer game. The second issue is that Unreal Engine's default chaos vehicle template has replicate movement enabled by default. This means that while the client is running its own physics simulation, the server is simultaneously sending transform updates that overwrite the locally simulated result. The outcome is jittering and unstable movement. If you're building your own vehicle system, make sure you don't fall into this trap. The biggest problem, however, is that physics simulation is not deterministic. If clients are running at different frame rates, their simulations will naturally produce different results. Even if every client runs at exactly the same FPS, floating point precision errors will eventually cause the simulations to diverge over time. As you can see, this leads to severe desynchronization, making the default approach impractical for a multiplayer vehicle game. The best solution to this problem is state synchronization. With this approach, both the client and the server continue running their own physics simulations. The server periodically compares its result with the client's result. If a difference is detected, the server notifies the client. The client then rewinds to the point where the error occurred and replays all of the stored inputs from that moment onward. This significantly reduces the accumulated error and keeps both simulations synchronized. Unfortunately, Unreal Engine currently implements this approach only for the character movement component. There are several plugins that attempt to provide similar functionality for physics-simulated objects, but at the moment, most of them are not mature enough for production use. That leaves us with the most practical solution, the client authoritative approach. With a client authoritative system, the physics simulation runs only on the machine controlling the vehicle. Instead of replicating the simulation itself, only essential data, such as the vehicle's location, rotation, and any other required state, is replicated to the other clients. Those clients then use a snapshot interpolation system to smoothly reconstruct the vehicle's movement. As a result, every instance sees the vehicle in the same position while maintaining smooth visual movement. That wraps up this video. The complete implementation, source code, and full tutorial are available on my Patreon. If you have any questions, feel free to join my Discord community. Thanks for watching. Don't forget to like the video, subscribe to the channel, and stay tuned for more Unreal Engine content. See you in the next video.